Good morning all. Welcome to this fourth and final session in our TruClient Tips and Tricks webinar series. With me, as always, Shlomi Nissim, TruClient R&D Manager, and Eyal Jacob from TruClient R&D, and myself, Lior, from the cost team. Now, to remind you all what we've had for the past month. We began with a functional overview, continued with deep dive into object identification. Our previous session last week was on advanced scripting techniques, and today our fourth and final session is a troubleshooting session on TruClient. Again, as with all our previous webinars, we encourage you to ask your questions during, but also to listen, as some of your questions may be answered online. Please refer your questions to everyone in the chat interface of WebEx. And again, if your question is unanswered online, worry not. We are collecting all questions, and as with our previous sessions, we will be publishing an organized Q&A page with all the questions and answers collected during the webinar. We wish you a pleasant webinar session today. This will be, again, slightly longer, scheduled for 90 minutes. And sit back, enjoy, and benefit from it. Okay, so without further ado, Shlomi, take it.
Thanks, Lior, and thanks everyone who decided to attend yet again. I really appreciate the time that you devote to these sessions. So the agenda for this session is quite long, and hopefully we'll be able to cover everything. I apologize in advance if we are not going to complete it all. In any case, we have arranged the slides in such a way that you can later on refer to them. It's like 80% of it, it's kind of self-explanatory, so you will be able to go over it and understand it on your own, alongside with the recording. So I hope, again, we will be able to cover everything, but if not, please excuse me in advance. In addition, as opposed to the previous sessions, where most of the session was hands-on, this session is going to be like, I don't know, around 20% hands-on, and the rest of it is going to be over slides. So again, I apologize in advance if it's going to get boring. So the content is basically first to understand the TruClient architecture and what IPC is all about. Later on, we'd like to educate you about how you can view the browser when you run it in load mode from controller, from Performance Center, in order to troubleshoot things. If you can see what's happening, it helps a lot in troubleshooting, so we'll teach you how to do that. How to use snapshot on error, when not to use it, and what happens if there is a problem with it. A word about virtual user log files, some troubleshooting around certificates or some education around certificates. Some tips regarding script robustness. We talked about it that in a single user, usually it's much easier to create a script and make sure that it runs. While when running with multiple virtual users over a longer period of time with many iterations, it is much more complicated. So a word about how to make it more robust. Some tips regarding running TruClient in load mode, and a word about each one of the browsers. This is pretty much it. Okay, before we'll continue with the topics, I'd like to, I've added the two links to two help pages that we have online. I'm not going to go into them right now, but just know that you have a troubleshooting page for general troubleshooting, including some browser-related troubleshooting, as well as load-related issues, and mainly about how to scale TruClient when you run a load test. So it's not like you can scale it that much, but there are some good tips in this page. Basically, whatever we know and some information that we thought makes sense to share with you, we embedded in these two pages. So please use it offline. Okay, let's start with the TruClient architecture. So basically, TruClient or any LoadRunner protocol runs in the context of MDRV process. MDRV stands for Mercury Driver. This process basically allows, on the one end, running the virtual user, which is running the script code, and on the other end, it allows communicating with the controller in order to provide data like transaction data, user-defined data points, and so on. So basically, like any other LoadRunner protocol, TruClient also has an MDRV process, and this MDRV process consists of some generic functionality which is embedded inside this process for any type of protocol. And basically, this kind of functionality, for example, allows you to report transaction to the controller, report user data point to the controller, interact with the log file. So all sorts of components that are basically common for all the LoadRunner protocols. In addition, TruClient has an extension for MDRV. So this Mercury driver was designed in such a way that you can extend it with your own logic. So each protocol has its own extension. TruClient has its own extension as well, which is doing things that are unique to TruClient. In addition, unlike other protocols, TruClient has the browser process. The browser process, as you can see, is a different one from the MDRV process. Like most of the protocols run, I think maybe all of them, run inside the MDRV process context, which means that there is one process which actually executes the script as well as doing all the other stuff that I just mentioned. While in TruClient, we can't actually host the browser process, which is the virtual user. We can't host it inside the MDRV process. And therefore, we have like Firefox, TruClient IE, or Chromium running in a separate process. In order for that to be able to communicate with MDRV, we've created some communication channel. Now, inside the browser process, we have TruClient browser extension. For each browser, there is a different extension, but there is a lot of shared code in between the browsers. And each one of these browser extensions basically interact with the browser services. It's kind of simplified what I did over here, but just to get you understanding roughly about it. So inside this browser extension, we have logic such as object identification, for example, and we have all sorts of modules that are basically interacting with the browser, like network listener in order to determine whether HTTP responses are done, for example, or Windows listener in order to identify if a new window or a new tab was opened, or DOM listener in order to understand if the user or some event happened in the application. So all these are actually modules, and there are a lot more of them. I just wanted to illustrate that. So this is where the virtual user actually runs, but it reports data to MDRV in order to get that functionality that I mentioned earlier satisfied, like reporting transaction, reporting data point, and so on. In order to accommodate that, we had to create a communication channel. And this communication channel is basically IPC, that message that you sometimes get when something fails. So inside the MDRV process, there is IPC server. IPC stands for inter-process communication. And in the browser, there is an IPC client, and these communicate over WebSocket. So this is basically a high-level architecture diagram. I hope that it's clear. I tried not to make it too technical, but I did. It was important for you to understand how it works, because when you see an IPC error, you need to understand the context of it. So going to IPC error. What happens if you get IPC connection to the browser is lost? So this error is only a symptom. It's not the root cause of the issue. Probably the root cause is that the browser is crashed or hanged, or maybe it's not getting enough processor time, and therefore the communication between MDRV and the browser is lost. MDRV is acting as a server, and it pings every browser every other interval. And if the browser is not responsive to this call from MDRV, or is not getting a ping from the browser, here I am, I'm alive, then it thinks that the browser is a zombie process, and instead of just keeping a zombie process in the operating system alive, MDRV decides to kill it. So I've seen many cases where people asking questions in forums. I get IPC connection error. I want a hotfix, and sometimes they are trying to apply an hotfix which is not relevant to their problem. You need to understand that there is no generic hotfix for it. There can be many different cases where the browser, for some reason, crashed. We have 3 different browsers that we support. Each one of them has its own logic. And there might be many different use cases for which it will crash or hang or whatever. So there is no generic hotfix for it. Don't accept any hotfix without carefully validating that this is a real resolution for your issue. Let me just clarify it a bit more. I have seen customers installing hotfix for IE because of an IPC connection to the browser is lost issue that I saw with Firefox. Obviously, it will not solve their issue. It might also damage things. Also, if you do have an issue with IE and you get an hotfix for IE, you need to check that it's for the same version and it's actually for the same issue. So if you get this kind of message, don't bother opening a post in a forum or something like that. Just open a ticket to support and urge it as fast as possible to get an hotfix, and we will take care of that. So I said that already. And if you want to troubleshoot that, you can use the Paint Windows in Load option, which I'll cover shortly, in order to spot what happened with the browser, whether the browser crashed and then you will not see anything, or it just hangs in there and then it's alive but it's not doing anything. So you will be able to use this option in order to troubleshoot it. Okay, so we mentioned Paint Windows in Load. Let's talk about how to view the browser in load mode. So there is an option which we call Paint Windows in Load. It is applicable when the LoadRunner agent runs as a process. So this option basically allows you to view the browser while the script runs in load mode. By default, when TruClient runs virtual users in load mode, it creates a different desktop and runs the virtual user process and MDRV process over there on that desktop. And the reason for that is because we would like to prevent users from interacting with the browser while it runs, in order to avoid human issues. Basically, we would like to run the browser in an isolated desktop of its own. And when you use this option, Paint Windows in Load, we do not create this different desktop, and we run the browser on the interactive desktop. So this option can be activated by going to the default CFG file we located in the script directory. And under the TruClient section of the default CFG, you need to change the value to 1 from 0, and then it will work. Let me quickly show you that. So I'm opening the default CFG file, and I'm looking for Paint Windows in Load. So this is the option. You see that by default it's 0, and it's located under the TruClient section. So this is what you need to do. Just change it to 1, and when you run it in load mode, you will see the browser. Oh, I need this window. Okay. So there is another option. If you don't want to modify the file, let's say that the file is uploaded to Performance Center and you don't want to download it, or the file is, or the script is already in the controller, and you don't want to modify the script files, you can also use paint_window_inload from the controller command line arguments in the group dialog. So each group in the controller has a group information dialog. One of the tabs over there, as I don't have controller currently installed, so I cannot demonstrate that, I'm sorry. But one of the tabs over there has an option to enter command line arguments for the virtual user. If you use paint_window_inload with 1 after it, it will do the same trick like paint windows in load in the default CFG. So this one maybe is preferred because you don't really need to modify a file, and you can just remove it without making a change in the script. What happens if the LoadRunner agent is running as a service? So in Performance Center, by default, the LoadRunner agent is configured to run as a service. Some customers change that to run as a process. Some LoadRunner customers change the LoadRunner agent to run as a service. But the majority of the Performance Center customers are using the LoadRunner agent as a service. So Paint Windows in Load is not applicable for this case, because when running TruClient under this configuration, when the LoadRunner agent runs as a service, any process that is spawned from the LoadRunner agent will run as a service as well. And services have their own desktop, which is it's called like the services desktop or session 0. And this desktop will not, we cannot actually control of whether the virtual user will run in that desktop or a different one. It's a kind of security measure, and we don't have control over it. So in order to view the browser under this condition, what you need to do is you need to run interactive services detection service. This is a Windows service that is that allows you to interact with the services desktop, and you can see in the details dialog of this service. Basically, you need to, when you run it, you need to make sure that this checkbox is turned on. If you fail doing so, you need to modify this registry entry. It's written over here. I'm not going to show that or cover that. When you will run, after configuring that, you need to restart the LoadRunner agent, the LoadRunner agent, and then after you restart that, when you will run TruClient virtual users, you will get this pop-up message on the interactive desktop. If you will click view the message, this is a Windows dialog. It's not TruClient. When you will click this link, this button over here, you will be directed into the services desktop, and you will be able to see the browser. By the way, if you are running Citrix or RDP protocol with Performance Center, and maybe RDP, no, but so I'm not sure if Citrix allows you to actually view the virtual user. I'm sorry, but it is applicable for any process with user interface that runs under the services session. So if you click on that, you will be able to interact with it. And then you need to make sure that once you are in there, you will have this dialog in order to return back into the interactive desktop. If you are going to just stay there without being active meaning moving just your mouse over, then Windows will kick you out after 30 seconds or something like that, because again, it's some kind of a security measure. So and you might lose also the connection to the remote desktop if you are connecting remotely. So this is the way you basically return to the interactive desktop, and then you can click on view the message again in order to see what's going on. Whenever you use this option, either paint windows in load or interactive services detection, we suggest that you use it with a single virtual user in order to troubleshoot things, unless you need to troubleshoot it with multiple virtual users. But then try to limit this number, not because it's not supported or something like that. It's just make it much harder to troubleshoot things, because you get a lot of windows, and each one of them is trying to get focus, and then it actually bothers you, and you cannot really control over what's going on. Also, try to restore. Don't forget to restore the settings back to default in order to make sure that subsequent tests from that script or on that machine will not be running in the wrong configuration. Okay, snapshot on error. Snapshot on error is the nothing much that I can elaborate. I think that it's pretty self-explanatory. It's very useful. Maybe you can try this option before using paint windows in load or interactive services detection option, and basically try to troubleshoot by looking at the snapshot when an error occurred. It is really important to really understand what you are seeing in that snapshot, because a lot of times I'm seeing customers complaining about object identification, and while actually the object doesn't appear on screen at all in the snapshot, and there's no and it actually explains why the object was not identified. So the snapshot on error can basically give you some hint of whether the object appeared and maybe TruClient didn't identify it, and then yes, it is an object identification issue, or the object doesn't appear on screen, and then maybe for some reason the application was not in the right state, and then we need to check not the object identification itself, but a step back or maybe a couple of steps back in order to understand how we reach into this situation. So this can be very, very helpful. The snapshot on error are collected. If there are multiple of them, all of them are collected as part of the result folder from the load generator, so you'll be able to see them offline. And also, you can interact with the snapshot on error while the test is running from the log window of the virtual user. If a snapshot is not created, it is purely because of the length of the temporary path for the virtual user. So this issue is more relevant when you run TruClient scripts with the Performance Center. The snapshot image is supposed to be created under the virtual user temporary folder, and then if the image is not created, usually it's basically due to the length of the path, and there is a limit on this length, basically, or a Windows limit of 260 characters. In Performance Center specifically, the naming convention for the temporary path is it happens to be really long. So it actually includes the name of the project from which you run the script, the name of the script. Sometimes it also includes a Performance Center or installation path. So it can get really long. Like, regardless of the additional extra characters that TruClient brings, it can get into 220 characters, 230 characters, and then when trying to concatenate the path under which we are trying to save the image of the snapshot, then we breach this 260 characters limit. So as a first measure, in order to avoid this issue, make sure that under the system variables, in the environment variables, you modify the default values of the temp and TMP environment variables from C Windows temp to dtemp or to ctemp or to something as short as possible. The reason for that is because whenever Performance Center identifies that this is the temp directory, it will not write under a system folder, and it will just concatenate a much longer path than what it should be. So if you modify that, then the temporary files will be saved over there. Even if you do that, you're still not off this issue. So there is a recommendation, but not a demand, a recommendation from us, not to install Performance Center in the default path. Use a shorter path. Like if you are doing a new installation, I will not ask anyone to change his current installation. But if you are doing a new one, just use something like that as opposed to program files, HP and the Performance Center. That is very long and will probably cause issues. Also, again, I will not ask anyone to modify anything of his current assets or her current assets. But if you can think about it for the future, try to use shorter project names or script names, because these are concatenated eventually to be a part of the virtual user temporary path. Putting that aside, we do have an hotfix for this issue, and we plan to embed it in the next release. So these are just best practices. The first one is mandatory. You have to exercise that. The second two, like with the Performance Center path and the project and script naming convention, it's really up to you. If you want to avoid issues, it's recommended. Okay. A short word regarding virtual user log files. These are also very useful for troubleshooting issues. By default, I recommend on using error only or even disabled. We have added in 12.53. We have added disabled. This is in order to minimize the amount of I/O that virtual user is doing. I/O is very intensive, and then it can also affect the CPU utilization and vice versa. So by default, I suggest that. If you need to troubleshoot something, if you encountered an issue, then you need to change it to standard level. There is no need to go to extended log. Extended log is probably only when TruClient R&D requested that. Okay, I will not even say the support team. The standard log level is sufficient in 95% of the cases. Please help us with it, because when we are getting support cases and we get extended log, it is extremely difficult to get oriented in there, and the resolution time is simply going to be longer. It's not going to help you, it's going to hurt you. So use standard log at a maximum unless you were requested. Extended log is very efficient only when there is a problem in HTTP level. It is rarely the case when it comes to TruClient. TruClient is agnostic to HTTP level. The only thing that TruClient is doing in the HTTP level is actually listening to HTTP requests and just directing data points and not actually handling anything with it. There is one exception with TruClient IE, and with TruClient IE, it is more likely that we will need to get extended log, and I'll elaborate on that later, or maybe Eyal will. So that is regarding the virtual user log. Just keep in mind that extended log is not needed, and try to use standard log at the maximum when you run it in a load test where the recommended is actually disabled or error only. Okay, 5 minutes about certificates, maybe even less than that. So client-side certificates and server exceptions. Server exceptions is relevant only for TruClient Firefox. Client-side certificate might be relevant to any browser. So we had a change in our design regarding that. In version 12.50, when we introduced TruClient Web, so we did a change in there, so I'll cover that shortly. And I know many of you are still using versions that are older than 12.50, so let's clarify what happened before that. So before 12.50, TruClient IE used the client certificate.pfx file in order to make sure that the client certificate is being installed in the browser when you run the script in the load generator or also in the Vuegen machine. This file is automatically created upon recording. Assuming you have the certificate for that application installed on your machine already, on your Windows machine already, and assuming the certificate password is exportable. This is critical because I think 80% or maybe even 90% of the cases that I have heard of so far were resolved when the customer changed the certificate file to have an exportable password, because usually it's not exportable. There's no reason to do that exportable unless you need it for some other tool or some other measure. So this is regarding CCPFX file. In TruClient Firefox, where we had the bigger change in between 12.50 and the previous versions, the certificate files are actually stored in several locations, but we managed on each Vuegen machine under a global profile, which is located under this path. We've managed the files that were actually stored in Firefox profile path. These are not TruClient files. So it's key3.db, cert8.db, and cert_overwrite.txt. There is a mistake over here with a comma. So these files are actually storing this information. Whenever you create a new script in Vuegen, then we go and copy these files and make sure that they are part of the newly created script, which means that if you configured the certificate or a server exception already and you create a new script, you will get that. The configuration needs to be done once for each application from Vuegen General Settings dialog. So it's the dialog that can be invoked from here when the browser is closed, not when the browser is open. So when you do that, and you basically interact with Firefox interface, and you make sure that the certificate is installed, it will be stored under this profile and then be copied to any new script. If you already have existing scripts, before you configure that from here, you can just copy the files, these 3 files, from this global profile into the existing scripts and override the existing copies, and then you should be okay. These files are considered as a runtime files by TruClient, and that means that they will be copied also to the load generator, making sure that the script is running properly over there as well. So starting 12.50, we've made a change. In 12.50, we've introduced TruClient Web. which is a unified protocol for all the 3 browsers that we support. And we wanted to make the client certificate model unified as well for all of the browsers, meaning that if you configure a certificate for a script, it will be applicable not only for the browser for which you configured in the beginning, it will be leveraged also by the other browsers. So instead of, this is the general settings dialog that I mentioned earlier, that for Firefox. So instead of seeing that in 12.50, you will see this client-side client certificate tab, which is the same thing that we used for TruClient IE. So instead of configure it over here, you can just attach a certificate. Basically, the model has changed, and we based our approach on the same approach that we did with TruClient IE. Now, if you have scripts, TruClient Firefox scripts from version which is earlier than 12.50, and they already have client certificate configured in them, it will work. There is not going to be any problem. If you create a new script, you need to use the new approach. If you will continue doing the same approach as in previous release, but only manually, basically manually copy certificate related files, those files, this key3.db and cert8.db and cert over itxt. If you copy them under the app data master profile, you will get it the behavior as it was in the previous version. It's a workaround. It is not we just kept the code as is, but we didn't expose the user interface to do that differently for Firefox right now. So we wanted to have like a unified approach for that. Server exceptions window, which is again unique for TruClient Firefox only. Basically, it's unique for Firefox. Is embedded from the general settings dialog inside the browser. Now, TruClient Web Mobile is based on Firefox browser. So in regards to TruClient Web Mobile, if any of you using it, there is no change in 12.50. In there, you will still get the same general settings dialog being invoked, and you have the user interface and so on. And actually, that will persist the data under the same master profile. So if you want a workaround, which is with the user interface for TruClient Firefox, and still continue to handle certificates as you did before 12.50, you can open TruClient Web Mobile, and then you will get it configured for TruClient Web as well, but only to Firefox. Now, the server exceptions, as I mentioned, when you will open the general settings dialog from the browser, you will get a server exception, and you will be able to add the exception over here. Just one last word regarding that. When it comes to TruClient Firefox, I'm hearing a lot of complaints and a lot of users struggling with it. First of all, TruClient has nothing to do with it, really. It's just TruClient just makes sure that the right files are being copied from one place to another. That's it. If you want to troubleshoot that, you can simply open the Firefox browser directly and test that. But if you do that, you need to test it with the Firefox browser that TruClient brings, and not with the Firefox browser that you have installed on your machine. Each one of them has a different profile, and this data is kept under a specific profile. It's a profile-based information, which means that if you validate it in Firefox and you say it's working, it doesn't mean anything. It still means that you didn't configure it in the right place. Now, when it comes to TruClient IE and TruClient Web in general, with that attached certificate dialog, I suggest that making sure that the that the private key is exportable, and you can read this L page, this online L page, and it gives you all the details you need in order to overcome that. Okay, let's move on to some script robustness, and then we will have some hands-on from these tiring slides. We've made a few points for guidelines over here. I'll cover them after a short demo. So let me switch to ViewGen, and I'll show you. Basically, I created 3 scripts that I want to cover under this context. So one of them is for error handling. So I want you to get familiar and oriented regarding the error handling capabilities that you have within TruClient. And basically also to show you the logic that you can control from outside the script. So let's start with that actually. So there is in the load section under the other tab, you have action on error and what TruClient is going to do when an error occurs. So in here, there are 3 options. Either to abort the script, there was an error, I don't want to continue. The default option is to continue to the next iteration, and then the script will start again, might succeed, might fail. And we've added also in 12.53 continue to the next step. So there are debates, functional debates around whether this option is really valid for a TruClient script. So I'll try to explain that later. But anyway, customers requested that, and we fulfilled. So these are the actions that you can take from outside the script itself. Within the script, you can do much more than that. I'll show you later on. But first, I wanted to show you some constructs of things that you can do. So the first thing is that there is a step called catch error. This catch error step, let me demonstrate that in a new action in order not to mess up with this one. And let's just drop a few steps. It doesn't really need to be anything. Note that in 12.53 you can just double click in the toolbox and the step is added. It's very convenient. So the catch step is basically catch any error of the previous step. The previous step is a fluid definition because I can group any number of steps that I want, like that. And right now, the previous step is that group. Okay, and if I ungroup those, do I have this option? No. If I remove this group, then the previous step is now this group step. So you can control whatever logic will be captured by this catch error step. Now, there are different types of errors that you can encounter. Object identification error, step arguments, step action, step timeout. Each one of them is different. Let's switch to this predefined script and see how it acts. So I have, in here I have resize browser step. And I did wrong arguments. Let's see how this resize browser step works. And let's, I had the B in here. This is how it works. But let's run this this step in this way. So I'll run the group step in order for the catch step to be captured. And as you can see, TruClient in interactive mode, it highlights you have an issue with this argument. It is the wrong argument. It doesn't meet the criteria for the arguments that you can add in here. But the catch step caught it, and then I report it to the log. And if I'll open the browser, I'll see that it's over here. So this is an example for how you can catch problems with step arguments. In most cases, it's irrelevant, but if you are using, let's say, JavaScript code in here and not plain text, and in your JavaScript code, you expect to get a number, and eventually you got a string instead of it. I don't know if you did like something tc.getParam, and you wanted to get this value from a parameter. So, and instead of a number, you got a string. So in that case, you will be able to capture that with step arguments type of error. So this is for step arguments. When you would like to deal with specifically with step action. So in here I have a step that deliberately fails in its action. When I'm replaying that, let's wait for the page to appear. When I'm replaying that, everything is good. When I'm doing something like that, and I reach into a 404. So this is a problem with the action. We didn't succeed to navigate to that URL, and because we failed, this catch step action will catch this kind of issue. And in here, we handle that by redirecting into the right URL. Let's play this step and see this group step and see how it acts. So it goes again to the same page, and the catch step caught it and handled the error. So you can imagine what you can do with that. Another example. So I probably deliberately caused an issue with the identification in here, or maybe not. And let's see. Okay, let's talk about it. I replay that once. I think this one is going to work. But then I'll deliberately fail that. So navigating again to HPE homepage. Waiting for network. This is yet again a problem that you can capture as well with catch error, and I'll show an example for that. In this case, the object was not found, and TruClient basically decided to terminate the virtual user. So I did that deliberately, and you can see that in here we've decided to use the exit step. So exit step basically allows you, it's under the flow control. You can use it from here, and it allows you to decide whether you wish to exit from the iteration. Exiting from the iteration means that TruClient will run the next action, the next iteration, in here with the fail status. So you can control also the status under which it ends. You can exit the virtual user altogether, which means that the script will basically stop. You can exit the action. If you have only one action in the script, then it will act pretty similar to how exit iteration acts. But if you have multiple action in the script, So TruClient will simply continue to the next section. So this is the exit action, which exit step, I'm sorry, which allows you to control also the flow and what you're going to do with it. I think I don't have to cover that because I explained already, but this is like an example for a catch step that catch any error where this error can happen either in the navigate or in this click on button. So basically it helps you recover from both of them. Let's see what I did over here. In this case, I decided to reload the current page. From our experience, it was from several support cases that we've handled. We saw that sometimes it helps. Like, let's say that you navigate to a URL and every, I don't know, 50 iterations, you get a step timeout because of the navigation. If you catch that step timeout and reload the page, in many cases you can actually recover that iteration and continue the script flow properly. And you can also report a message to the log indicating that it happened in case you don't want to lose something like that, because sometimes it can be a real application issue which you need to analyze and to explore. Also, a more advanced use case is basically to do that in a for loop. So let's see what I did over here. I'm navigating to HPE Home again, and then I didn't settle with one action of recovery. I did a for loop and try to reload the page. And in case I identify this element over here, so I determine that the page is loaded correctly, and I can break the for loop, and I can basically continue the script flow in the subsequent steps. But if this object doesn't exist, then the for loop will happen again, and TruClient will try to reload the page again until this image found, or until the number of iteration meets the condition. So if you didn't find it also in the last iteration, so you can add also additional logic in here in order to exit the iteration, for example, or something like that. So basically, as you can see, it is very, very flexible, and you can do a lot of different constructs to manage and manage errors in the script. Let's see some more examples for how to deal with the application context in this case. Okay, so I have one example in here that shows the application state basically, and how can we deal with that. It doesn't have a catch error in here, but we'll just have a look and see how it looks like. When I'm navigating again to hpe.com, I can see that this website looks a bit different when I'm resizing the screen. When it looks like that, I don't have the top menu in here. Instead, I have the menu in here. So obviously, if I'm not going to consider that in my script might fail, and this might be an issue. So you need to keep in mind that when you develop your script on your desktop, you have a certain screen resolution. Sometimes in the load generator, you will have a smaller screen resolution, especially if the script is running from Performance Center under the services desktop, as I mentioned earlier, because services desktop is limited in the screen resolution. So there is a a workaround for that, and you can handle that. But you can also consider making sure that the script is aware of that. So in here I have a simple step. If the menu exists, then what I want to do is just click on that menu and click on the products menu item to do what I want. If that menu doesn't exist, then I will click on this element and see the products. Now, whenever I'm using a step, an object exists step, in order to control the application state, and I'm not sure what is going to be, usually I'm lowering the object identification timeout. I don't use the 20 seconds timeout by default. This is my personal usage. You can do something else, but I don't want the script to wait for too long. Usually TruClient finds the object much faster and you don't need to worry about it. What you do need to take into consideration in such a case is that the end event for the previous step secures the application state and make sure that this object that we interact right after this step ends is really available at that time. Let's see another example. In this example, I did some kind of recovery mechanism. So this function basically goes to this form. It's a very naive form, and I deliberately made a mistake while filling this form. I did in the object identification, I clicked on that and typed the company, I'm sorry, the email and the password, and right after that in here I click on this checkbox. So I deliberately changed this object identification in here not to be the correct one, but I wanted to show you the construct, and this is why I added this if I equals 1. So I wanted you to see basically when I'm getting into this loop, in this function, I'm basically first of all creating myself a flag, a Boolean flag of that indicates if an error occurred or not, and I'm setting it as a false. As long as I didn't get an error, it's false. I'm also making sure that this value is going to be reinitialized in the context of the for loop. I could have just do it in the for loop itself. Then I'm starting to fill the form. This is just for the demonstration purpose. When I'll reach into when I'll be in the iteration with I equals 1, it will fail basically identifying this object, which means that this catch step will catch that and mention that an error occurred. We'll report it to the log, and eventually in here we see that if we didn't have an error, then we will break. But since in the first time we will have an error, we will not break. We will continue to execute this loop. And in the second time, because we don't enter to this failing step, the catch step will not catch anything. Error occurred will remain false, and we will break out of this loop and continue to the script. So if you do something like that, and I deliberately did it, like I've implemented it right now in call function step, in order to provide you an example for how you can implement your functions in a way that they will basically handle a specific part of logic in your application and make sure that they are self-contained and they handle their own errors. And the rest of the script is not supposed to be aware of what's going on. Let's replay that and see how it looks like. Replay succeeded. Oh, because I replayed that before that once and I didn't run into the iteration. I'm sorry. I'll have to disable that and replay it again. Okay, I will not troubleshoot it right now. I'm not sure why. Yeah. I'll need to do something like that. Apologize. My bad. Let's see it. In the first time now, it will try to identify this object and will fail. And then in the second time, it will not go into that step and it will succeed. So this is yet another example. Closing this one, and we are running out of time. But I will show the last hands-on example over here, and then we will continue. Authentication step is a step that I've heard a lot of issues and people struggling with, so I decided to cover that. In TruClient, when during recording, when it records the authentication step, it automatically creates a group step like that, navigate to a specific URL with 2 steps embedded inside that group step. The 2 steps are the actual navigation and enter credentials in the dialog. Now, in the previous versions, we had a bug in that logic, and instead of automatically assign dialog opened, as you see over here, as the end event for the navigation step, the automatically assigned value was action completed. So this is a source of problem, and it can be easily modified manually, and you can avoid the issue by manually changing it to dialog opened. But users are not aware of that, and because of that, their scripts keep on failing every once in a while, and they don't know why. So the reason for that is because when you navigate and the end event is action completed, the navigation, the instruction to navigate completes very fast, and TruClient moves on to the next step. But the authentication dialog pops up only when the script, the document was actually returned back from the server, or at least some network responses came back, HTTP responses came back, and then the authentication dialog appears. So as long as this dialog doesn't appear, then we'll fail. So basically, when the end event is action completed, TruClient moves to the enter credential step, and then it sees that there is no authentication dialog and fails. In 12.53, we made sure that these kind of steps will be sensitive to object timeout. They were not sensitive to object timeout, so we will be more tolerate about delays in waiting until this authentication dialog appears. But before 12.53, it was not like that. So I do advise changing the end event to dialog opened, as it is by default in 12.53, and also make sure that you add a catch error step after the enter credentials, making sure that maybe you try some recovery. But if you're using 12.53, you are good to go, and I think that this the change that we have done is good. So this is in regards to the default. Now you can set authentication step again, starting 12.53. You can set it as optional, which means that I've heard cases where you replay the script in interactive mode or in the Vusion machine, you don't need to authenticate, and when you run it on the load generator, you do need to authenticate. So you can avoid issues around that either by making sure that the user, in both cases, both on the load generator and on the Vusion machine, behaves the same, like either doesn't pass the NTLM authentication automatically, or fails in both cases, and then you will not need to handle any anomaly. But if you don't do that, you can set the authentication step as optional. This means that if the authentication step appears, TruClient will perform it. If it doesn't appear, TruClient will just wait a bit and then skip the step and will not fail the script. Last thing is, I think that I already mentioned that regarding authentication. You can add a catch step. Usually inside the catch step, if you will put reload page and try to authenticate again, it can help. So if you don't have 12.53 and you cannot use this optional button, then you can use this option basically. Press OK on dialog. If it fails, catch step will catch it. If you just want to avoid and not do anything, you can leave this catch step empty, and TruClient will just continue to subsequent step and ignore that error. But if you do need to handle that, you can put some steps inside. So this is in regards to authentication. Going back to the slides. So in here we wrote some instructions of how to make your script more robust. So basically, you can add verification points to make sure that the application is in the right state. Use if exist or if exist, and then with some flow control to control what you are doing. Also, try to minimize the amount of I/O operations, especially do not run virtual users with extended log. It is not recommended, and it will just cause more I/O activity and more CPU utilization, and will impact the performance of the load generator. If you run your scripts in a load generator with smaller screen resolution, or if the LoadRunner agent is configured to run as a service and the virtual user eventually runs under the services desktop, you can use this option again in 12.53. For Firefox, we had another alternative in earlier versions, but for 12.53, it is applicable for both Firefox and IE, and Chrome is out of the hook for that, so you don't need to worry about it. But you can apply the size on the inner window. In case you do that, the TruClient, when the browser is being resized, it will, or if you use this option, it will resize the internal part of the browser, like this frame where you see the application, and not the window itself. So the window will still be in a fixed size, and the resize will happen on the content window. So this is very useful in order to overcome screen resolution related issues. If your script is working with multiple windows or tabs, you can use activate window before you perform an operation on that tab. Especially with TruClient Firefox, when there are multiple virtual users with application with multiple windows, the focus of the window between is actually being lost, and virtual users might affect one another. If you use activate Windows step in the script before you try to interact with an element in the application, it will reduce almost to zero the amount of errors that you get. And also try to reduce the amount of steps that you have in the script or in the action. Try to manage your script in such a way that it will be more easily maintained. I oftentimes see customer scripts with 300 steps and like 100 steps that are in level 2 or level 3. I don't understand how you can manage that. I think it's very, very difficult. I salute you actually, but I think it's going to be more convenient. It's going to be more easy to maintain the script if you divide the logic into logical units, and basically each unit takes care of its own recovery. So we already went through this demo, and we can move on to the next section. Basically, it will probably be our last one, and it's running TruClient in a load test. So Eyal is going to give us is going to run these slides, and for the remaining slides, we will definitely share the presentation. And if you have any question, don't hesitate contacting us. So Eyal, the stage is yours.
Morning, everyone. So I'm going to talk about running a TruClient in load mode. We're going to discuss about scalability a bit. So as you can see from this slide, the usability is high on GUI level protocols, and as long as the usability is high, the scalability is a bit lower, which means you can raise a bit less processes on that case. But the usability drops down as you go down the layers. So I'm going to talk about running TruClient in load test. We've added a useful blog post so you can read about it a bit when you get the slides offline. TruClient in general launches a browser for each virtual user. Each browser has its own memory consumption, so there is no fixed number of virtual users per load generator. It is actually calculated per script. The CPU utilization should not exceed 70%. And the memory utilization, in general, you need to decrease 1 GB from total memory, which utilized by system resources. You also get a GDI limitation, and you need, well, it is suggested to use gradual ramp up, calculate per script, and avoid aggressive initialization. Well, CPU utilization is AUT specific. It may vary between different AUTs and the browser being used. Different browsers use different CPU and memory. They consume different resources. And they also include different management mechanisms for resources. So when you run load test on different browsers, you need to take that into considerations. The CPU in general affects browser performance and load measurements, meaning the less CPU time for each process, therefore less time to perform browser actions. So you might expect slow transaction response time, slow page rendering, and object identification timeouts. As long as you raise more browsers, that means each browser gets less CPU time. So it needs to be checked per AUT. Okay, the CPU utilization and the effects of it might get virtual user stuck initialization stage for a long time. Overutilizing the CPU might delay the browser start time, meaning each browser takes its own time to initialize. Okay, the MTRV process will wait until the browser starts and then negotiate, as Shlomi mentioned, via IPC. What I would like to talk about is this stage, we have experienced a lot of cases in which a user starts a lot of virtual user on the LG. Each process tries to start. When a process tries to start, it communicates via IPC to MDRV. Now, if you get more processes running, it will take a bit more time for each CPU to communicate with MDRV, which might result in IPC connection to the browser issues. Okay, so there is another mechanism that we've added basically since 12.0. This is a keep alive message between MDRV and the browser process. So for each browser that runs, MDRV checks with it if it's still responsive. In case it is still responsive, then everything is okay, and when it stops responding to messages, we assume that the connection is down and the browser is lost. So overutilizing the CPU might delay the keep alive messages, since each browser has less time to respond, and resulting with MDRV assuming the connection is down. So how can I actually reduce the CPU utilization? We can reduce the amount of virtual user per load generator, start less browsers which communicate with the MDRV. We can use gradual ramp up. Gradual ramp up will allow each virtual user to communicate with the MDRV process with less issues. We can use a wait step. Well, it depends on the script, but you can simply add a wait step for 3 or 5 seconds every couple of steps, or even 2 or 3 wait steps in the script might make a difference on CPU utilization. For CPU utilization, you can use, again, a C step with sleep. The difference between wait step and evaluate C step, which takes sleep for 3 seconds or 5 seconds, is that the evaluation is performed on the MDRV side. While it is being performed, the browser actually waits and suspends the main thread of the browser. So it gives additional time for the CPU to handle other processes. We can also add a pacing between iterations. Start iteration after previous iteration ends with a fixed delay of 10 seconds or more even. Increase the interval between steps, the interstep interval, set it to 500 milliseconds. Maybe by default, I think it's 500 milliseconds. You can increase it to a second or more, or even upgrade the hardware. Just a note about the hardware. Even if you upgrade the hardware and get a bigger memory and more logical processors, you might still encounter what is called a graphic device interface exhaustion. When a browser renders the AUT or any graphical element to the screen, it uses a graphical device interface object. So Windows has a limitation for the amount of GDI objects that can be created. By default, I think it's 65, around 65,000 objects, and Windows take not major, but it takes a part of it. So you might still encounter this limitation. Memory utilization is also something that you need to consider. The CPU utilization is the same actually as memory utilization. It may vary between different AUTs and the browser being used. Each browser consumes its own memory and allocates memory to the AUT depending on its logic. So the memory will affect the browser performance and load measurements. It might increase the disk write using the page files. If we consume more memory, Windows or the operating system would try to write data to the page file, results with transaction response time, and might even result with slow page rendering and object identification timeouts. We've encountered a couple of times that the users are stuck in initialization state, or they crash at the start. It might vary between two issues. The first one is low memory, which might delay the browser start time, and the MDV process will wait until the browser starts and negotiate via IPC, or we might encounter the GDI limitation. Therefore, the user will either stop on initialization state or crash at start. So to overcome the GDI limitation that I've mentioned, in PC you can use terminal sessions. In PC and LoadRunner, actually, you can use a terminal session to start a new session after a specific amount of virtual users. To measure the GDI that your application consumes, you can start one virtual user as a process and use the task manager to observe the GDI objects being used. Okay. After you observe that, you can calculate the amount of virtual user approximately you can run on the load generator according to the limitation of the operating system. And then you can go to the configuration. You can select the load generator, and here you have properties that you can configure terminal sessions and the amount of user you want to run per terminal sessions. So you check the checkbox, enable terminal sessions. You define the number of terminal sessions you want and how many virtual users you want to run per session, and create a new terminal session. Just note that the terminal session in PC is created using ISR Metro user. So you need to make sure you can remote connect to it. In LoadRunner, you can configure the same thing using the load generator configuration screen. You just select the load generator and click on details. And on the details, you have a tab which called terminal sessions. You can enable it, select the number of terminal sessions, and define the number of virtual user per terminal session. You can select to either connect to existing terminal session or create a new terminal services session and define the username, password, and domain being used for the connection. We actually going to write a blog about it and post it later on. We might share the link to that blog, and you can view how to configure the LG to support terminal sessions and how to configure it in Botest. That's it for now. Just a second, I will transfer it to Shlomi.
Thanks a lot, Eyal. So we, again, thank you. We're truly sorry for not being able to cover the browser-specific content. Basically, the slides in here, again, as I said, are pretty self-explanatory. So you have several slides for TruClient IE, several slides for TruClient Firefox, and several slides for TruClient Chromium. Basically, each one of those are just a few facts about the browser and some very common troubleshooting regarding those browsers, and definitely we'll share these slide decks. I would like to thank Lior for accommodating this series, and I'd like to thank all the customers who joined and all the sessions. So we really enjoyed, and hopefully we'll be in touch. Bye-bye.
Thank you, Shlomi. Thank you, Eyal. And thank you all for joining this webinar series. This was truly an exciting experience for us as well. We appreciate the time you took. We will be sharing this recording, of course, along with the organized Q&A session once it is resolved. The session will be uploaded to the FTP site by the end of today, and you can access the same site, the same FTP details that you have from the previous sessions, but we will send an organized email on it once it's there for sure. Again, reminding you about the TruClient LinkedIn group and the forums. And really just a big thank you from us all. Any questions you still have on issues you've seen here in these webinars, or things you want to share, you want to ask, programs you wish to join, feel free to email us at plv_cost@hp.com, and we will be happy to contact you and continue with this. So have a great rest of the day. Thank you for attending this series, and bye-bye now.